So now that you have your data all processed, you have your graphs made, now you need to run your statistical tests. So you cannot say just from observing whether or not your treatment had an effect or not. In order to do that, you have to run one of the statistical tests to see if there is actually a statistically significant difference between your different groups. So for our purposes, your choices are either the ANOVA or the t-test, and it literally does not matter which one you pick. Um, it just depends, like, what do you want to say with it? So a t-test is going to allow you to compare each group against your control. This is comparing two groups at a time and saying if there's a difference between them. Versus an ANOVA is going to compare all the groups at once and say if there's any difference between any of the groups. So again, it doesn't matter which one you use, but in your analysis section, you do have to state which one you're using, define it, what it is, and when it is appropriate to use it, and be sure that you understand what that test is actually telling you. So the t-test, let's start with the t-test. Let's say you want to compare each group against your control. So the t-test is a statistical test that's going to compare the means of two groups with, again, similar variance. So meaning the differences between your different data points are expected to be more or less the same. We're going to use a two-tailed test, t-test, to compare if the difference is either greater or less. We don't care if the averages are larger or smaller. We want to throw a large net and see if there's any difference at all. And if you're going to use the t-test, we are almost always doing an unpaired t-test because you were testing your controls versus your conditions on totally different plants or totally different bacteria. It's only paired if it's in the same organism. So the t-test that we will be using will be two-tailed. Again, we don't care if the differences are larger or smaller. We just want to see if there's any difference. And unpaired because the organisms that you were testing were in totally different groups. So in order to do this, you have to find and reference some sort of online t-test calculator. Again, I don't care which one it is, but make sure you add it to your references unless you want to do these calculations by hand, and I don't think that you do. So what you're going to do is you're going to look up a t-test online calculator, enter the data for your groups, and then calculate some kind of p-value and report those p-values in your internal assessment. So let's go ahead and look at what that looks like. So I'm legitimately going to just go over here and do online t-test calculator because who knows? Okay, let's just go with the first one. It probably doesn't matter which one you have. So again, choosing the right one, we are using an unpaired t-test because you're testing on different organisms. And I think it's going to automatically give us a p-value of 0.05 or not, or higher. And notice that there is a group one and group two. So for your group one, you don't have to type this, but I'm going to just go ahead and type it. So you'll compare control. Let's see what we had over here. So let's say that we're comparing our control of 18 degrees. Let's say this is our control. And I'm going to copy this and put it over here. Of course, it's not going to go. Of course not, would be that easy. So I'm just putting one value per line. Again, guys, when you're doing this, make sure that you don't have letters anywhere in your data or it's going to totally mess with your data. It's going to be really sad. I think this one, I can't tell if it's getting rid of the spaces for me. I don't think it is. No. So I have let's say I make my control 18 degrees here. So for t-test, you're going to just compare one group at a time. And so let's say I want to do the 18 degrees, and I have that as my control because that's temperature, it's room temperature. And let's say my first group that I want to test, is there a difference or not, is the 4 degrees Celsius. Doesn't matter. You get these numbers in here somehow. You can copy and paste them one at a time. You can type them. It doesn't matter. I'm just being lazy here because I don't want to type a million numbers. Nope. Right. I'm going to enter that one. And I'm clicking through to make sure I don't have any like weird spaces that could potentially mess this calculator up because who knows what's going on with the programming. Okay, So once I have my group one and group two, um, I am going to hit calculate now. And so this is the numbers that I want. So this p-value, 0.602, this is what I would take, right? So say in my IA, if I'm doing the t-test, so right, in statistical test, I would have some sort of title that says statistical tests. And then I would say the t-test, what it is, when it's used, why I'm using it, why I'm using it, and what it actually is telling me. So if I was doing t-test, I'm probably going to have a bunch of groups to report. So I would probably just make like a table if it were me, right? So I would say p-value of treatment group versus whatever control. So that one, it was 4 degrees. If I could put that here. And the p-value for this one is 0.069. And let's go ahead and be two-tailed. And don't forget to put your reference here. So you would go ahead and repeat that for each of your groups. You can include this stuff. You would snip it and put it in there. So that's what you would do for your t-test. Again, you would have to repeat this for each group. So control 18 degrees versus your, I don't know, 28 degrees. So you would repeat that process for every single one for your t-test, if that's the one that you're using.